Приветствую подписчиков моего канала. Продолжаем изучать концепцию Стенли Мейера. И недавно мне пришла ссылка в Дискорде, где мне предложили выступить в качестве оратора на конференции, видеоконференции. Эта видеоконференция была организована Крисом Бейком. Здесь участвовали в видеоконференции Пол, Саймон Босолей, Этан Кроуден. Я участвовал, но я не стал участвовать в качестве оратора, так как я не знаю английский язык. Значит, я пользуюсь Google переводчиком, а также нейросетью Яндекса для перевода видеоматериалов. Соответственно, сказать на русском языке, в англоязычной среде это не совсем меня правильно поймут, потому что у них тоже нету нейросети, чтобы аудио расшифровывать мое. И, в общем говоря, я просто просидел и прослушал 2 часа, что здесь происходит. Ссылкой я поделился с Сергеем Проектировщиком, также поделился ссылкой с Сергеем Пацинко. В общем, вот этих вот людей я пригласил тоже на эту видеоконференцию. Но модератором его был Крис Бейк, и в качестве оратора из российского сегмента право выступить он дал только мне. Но я от этого права отказался ввиду незнания английского языка. Собственно говоря, Сергей Проектировщик подключился где-то спустя час. Можете у него спросить о его впечатлениях. Собственно говоря, я сейчас запускаю небольшой 12-минутный ролик, в котором как раз описывается, что происходит. На это у меня вступительное слово все. Дальше слушайте, о чем говорят люди из Шотландии, из Британии и Соединенных Штатов.
More because you've got 20 volts being held between the pulse trains. On the other one, you've got nothing between the pulse trains. So you've effectively got a massive, great big pulse on the top trace. Correct?
That is correct.
Relatively speaking, you've got a big pulse on the top train between your groups of pulses, and I think that's why you're getting more on those tubes. Is that right?
Yeah.
Does that make sense?
Yeah.
Right.
Yeah, that's totally what it is. Yeah.
Okay.
Yeah.
Yeah, sorry, I was a bit slow at understanding what you're saying, but I got there by explaining it to myself in a way, didn't I? Yeah, I've got it now.
I can get that. Oops, not that way. I can't see it anyway. 4.6.
How long are your tubes, Chris?
Standard resonant cavity issue.
Oh, right. Yeah.
So, but the one that's on all the time now, the majority of the time, that's not going to be, it's going to be perhaps more current restricted because it's got the resistive filament in there. So the amplitude effectively reaching the tubes in that arrangement now is going to change from what we're seeing here. Here we got full amplitude.
Mm-hmm.
But going through the light bulb, we would see a much diminished amplitude during that, off time that's where continuous DC is applied.
Mm-hmm.
So yeah, it may balance back out then. And interestingly enough, in this arrangement, varying the gate off time has no real effect on current. So like with I just had the just with the standard pulse, right? If I was to decrease the gate, yeah, current is variable. It's directly proportionate. Sorry, it's inversely proportionate to gate off time. As the gate comes in, current goes up, right? But in this arrangement here, it's constant. So in fact, the way to reduce current is to pulse it more. So from what we effectively, I got a trigger here, hold on.
Just finesse what you said there, Chris, to say that in this arrangement, the current isn't changing. Okay, you can presumably you can see that not changing, right? You can see it on your ammeter, right?
Yeah, let me clarify. It goes down the more we pulse.
Right.
So right here we're at 4 watts.
Yeah, bring the gate in. Yeah.
We're at 3 watts.
Fascinating.
We decreased 25 a whole watt by bringing that in because it's about turning it off more times than it's on.
Yeah. And does gas yield change in proportion to gate as well? Or is it? We have to let it settle for a bit because of course you're going to get.
Yeah, I don't know.
It's not an instantaneous change. I realise. Just curious.
The difference between 3 watts and 4 watts might be a little hard to detect.
Yeah.
Well, we're setting 3, I guess. I would suspect that it would increase. Yeah. So now if I turn it down, I'm going to turn the gate farther way out. Yeah. We're now back up to like 4 watts.
I
think, a little bit. But it's not a big fluctuation because you're already at your max current that's going to be used. So we're varying how much we turn it off. Unless, now if I add more pulses like this, current goes down. Now we're back to 3. So let's zoom out a little bit.
Yeah.
Now we're back to 3 watts because we.
In a given frame, total amount of off time is increased, isn't it?
Yeah. Attenuation. That's what's meant by attenuation.
Well, there's 2 ways. You can either attenuate by changing amplitude, or you can attenuate by the frequency with which you're applying a signal.
Well, pulses per
second. Oh, hang on, is that right?
No,
it's not.
Well, it is. Pulses per second doesn't mean frequency. If you think about it, it's kind of decoupled from frequency. It's more like the gate allows X number of pulses. There's still a second. There's still real time over top of that. Like a second's going to transpire or elapse. But you've got like one gate period that only has 10 pulses in it. Well, that's 10 pulses in that. If the gate was set to a 1 second, think about it like that, then you would have like 10 pulses, or you could have 100 pulses in that same second. So that doesn't mean the frequency. That just means the number of pulses in the train.
Yeah, right. And that could be another way of understanding attenuation, couldn't it? Huh.
Yeah, right.
Interesting. Hadn't thought of that before.
Have you tried turning it off?
Sorry?
Oh, it's just a joke. It's like, have you tried turning it off?
I'm just going to get our door. Hold on.
Yeah. Hey, Nemo. How you doing?
Outside. It's cold. It's not there. It's getting that cold.
We invite him to speak.
Oh, sorry. Oh, we've got somebody calling us. All right.
I invited him to speak. I don't know if we can understand each other. See if he joins.
Enough.
Where's Tony?
I've got a button. that says invite.
Did you say, Tom?
I've got a button on my bottom left of my screen that says invite, Chris. Do I need to push that?
I think it just, if you want to add anybody, you can do that.
Oh, I see. Oh, yeah, right, got it. Yeah.
Just Slade, let's come share it.
Well, apparently we can message our caller by. I'll try that. I'll try and say hello.
Okay. Oh, Donatelli.
What?
Huh?
Donatelli's?
No, just he's got like 4 new videos today. His schematic.
Really?
I actually looked at the schematic he showed. He like puts all the pictures and stamps cards on there and the GMS boards, and then he
How much
draws,
more
like,
of the? How much more of our shit is he stolen?
I haven't seen anything in a while. I've been looking, everyone. I haven't seen it. I thought for sure we'd see those new pictures, but he hasn't.
Little cockroach.
Very strange. Like he shows the schematic and he's got like the distributor pack of the car with a line going to the big bobbin and then going to the fuel injector. It's like, what? Like, dude, do you even know how this works?
They mixing up a bunch of components to make like it's an elaborate system, but
Yeah.
mostly off-the-shelf diagram from those like propane injection system that he just jerry-rigged a bunch of star parts on top of it. And
Yeah. It's bad.
Confusing fellow. Don't know what to make of him really. Just think best thing to do is completely ignore him.
Squash the roach.
That's a bit extreme.
You know what's interesting though? When I turn both of these on and I try to do the same behavior, like I expect, you know, internally we could, if I had an ammeter on each leg, we could probably see one going up and one going down. But the net result is that current doesn't change. If I can make any adjustment, the current doesn't change. It's spread it farther apart because it's equally balanced. What I turn off on the bottom one, I'm turning on the top one, right? No changing.
Oh, just a stupid question to ask. I'm sorry to ask it, but these two signals are going to different tube sets. They're not going to the same tube set, are
Right. They're sharing a ground in the center. Like
Yeah.
the very last electrode, it goes to ground, but then the outer inputs, outer anodes, are going to two separate transistor drivers. Yeah.
Right.
I say drivers.
And each of which is driving 3 tube sets. Yeah.
Yeah, in series,
I was going to ask that in series. Okay. Yeah. Right.
in natural water,
Mm-hmm.
rainwater. Yeah, it's interesting because like it's equally balanced. So what current you're using right now, it's like it's almost constant. It's never going to change regardless of how many pulses or what your gate time is.
Huh.
Because it's just what we gain on one side, we lose on the other, back and forth. Yeah, I mean, this really wasn't Stan's arrangement. Like I said, we're going to have the light bulb in there, which is going to reduce the amplitude of the inverted channel. Or at least restrict the current of the inverted channel, which may be better too than. Maybe put the light bulb in series and see what happens. Why didn't I think of that? Oh, that's not what we need to put it on this one. Okay, so now we got 120 volt, 40 watt light bulb. Series with inverted signal. Yeah, so we're at 4.3. We lost about half of a watt. I guess that wasn't that significant. Get back to lunch over here.
Oh, you got a threshold.